to our session regarding AI from Accenture and Siemens together. And looking back of the last Hannover Fair and this fair, AI has changed tremendously. I mean, in a speed we didn't encounter and envisioned even. Today, agentic AI systems are not just answer questions, but they are planning, checking, and acting. And what was for me so tremendous is looking at OpenClaw, one of those orchestration systems, 6 months ago started and already has more than React or even Linux on GitHub. It's a favorite. I think decades of communities have not much more favorites than OpenClaw only after 6 months. And every major player right now has an agentic AI system which has multi-step approach with little humans in the loop, if at all. And of course, when you look at our innovation area there, you will see how Siemens envisions agentic AI moving from a chatbot into a co-worker on the shop floor. This is what we want to talk about today in our session. And I would let's get started on this discussion. So, Ralf, looking about what we are doing with agentic AI and what we are doing with especially autonomous operation, when it comes to manufacturing, what do you think about autonomous operation? What are your ideas and where do you think are we going and heading?
So in manufacturing production, when we talk about autonomous operations, we actually mean an AI-centric system with agents which increase the independency and the interference of and reduce the manual interference of humans in the production process overall. So many companies see this as part of their digital transformation, and this is actually the right way of looking at it. So they implement SCADA systems, they implement MES, they implement IoT, they implement PLM system, which is a very good foundational starting point to get actually to what we call autonomous operations. Because then the next step, and this is what we will talk in the next 10 minutes or so a little bit more, is you need to add context to that data systems. Because system data sitting in MES and IoT and PLM are typically still a little bit siloed today. So actually an industrial knowledge graph helps you to get these data together and contextualize those. And if you then add an agentic system on top of it, which actually can utilize the capabilities of MES, IoT, PLM systems, as well as being guided through the relationships that is being created between these data silos with an industrial knowledge graph, then you have enough kind of power put together, which then gets you to something which is close to autonomous production, where you can reduce actually the human interference stepwise over time. And if we think about this in that way, Vlad, where do you think we are today and how long does it take us to get there?
Yes, so what we see today is that manufacturers are already applying AI in the vertical solutions. So we have powerful AI solution to use it in planning, for example, in solutioning of a product itself, in maintenance. But what we are missing in many cases is a cross-solution integration. It's this horizontal integration. So many manufacturers are optimizing the steps, but they miss the opportunity to optimize the end-to-end workflows. And it's not a question of a technology in the first place. It's about the scalable application of a framework behind and red data foundation. I frequently often compare it to autonomous driving, where a lot of value can actually be created without a full autonomy, but it's important to apply it in the areas where AI already today can deliver cost improvements and efficiency.
So having heard all of this, Ronnie, Siemens is a company with many factories around the world. Does Siemens apply these kind of approaches, what we heard from Vlad and the definition of what autonomous operation means? Do we apply this in Siemens factories?
Sure. I mean, I think Roland Busch and Jensen Huang announced one of our cooperations there in a factory in Erlangen, in the electronic factory Erlangen, with our partnership with NVIDIA, for example, we are right now investigating how we can use physical AI and also agentic AI use cases on the shop floor, in the factory, on operations level, depending on the urgency of the customers right now. Also our internal customers, also we treat our factories as customers. And together with NVIDIA, we are evaluating right now different use cases. And by the way, some of those are inspiring also our areas here. So when you look at the Innovation Hub area, there are 2 robots doing picking, flexible grasping. And this is a wave 3 use case. So we use VLMA, so visual language action models. Yeah, that's the buzzword right now. Where we have a system which is not trained on every step, but is really trying to identify what do I need to grasp. And this is in Erlangen, for example, for picking stuff and putting into boxes. This is what we are evaluating there, for example, one of those use cases. Another one, also in Erlangen right now, we are investigating something we call autonomous production planning, where it's really about rescheduling and reacting to changes in material flow. So Erlangen is a high variancy bit frequency factory, which means we have 1,000 different products, we have 24,000 materials. And imagine when one part is missing of a truck reaching to the factory, what are you doing then? Yeah, so how can you reschedule? How can you adapt? And this is also inspiring our work with Accenture, for example, also in the Innovation Hub. In the middle, when you go there, you will see a flexible production use case where we discussed also not about how Siemens doing it in orchestration, multiple agents coming together, but also we know that our customers are not Siemens shops from end to end. So how can Accenture come here, support the orchestration of orchestration systems, for example, in this factory? And third, but not least, when you look there with agents right now, Pepsi, we are doing, agents are supporting there with the pop-up factories. So imagine the Soccer World Cup right now. You have different kinds of teams coming together, semi-finals, finals. We don't know, Pepsi does not know where to do. So the Gatorade production, agents will support there and help. What kind of Gatorade product do I need then on the different sites? That's, yeah.
Yeah, great. Ronnie, thank you very much. I believe also this is the reason why people join sessions like this. Yes, to see the real life examples, how AI can be applied today. We see many cases today. Ralph, maybe you could share one example where AI today already, on concrete example, can help to get insights faster, to be more efficient, and came faster to right actions.
So let's get to a very concrete example down to the machine level. Imagine an injection molding machine producing certain plastic parts, and an agent is detecting that there is variations in quality because of difference in size. You want to have constant size and not sometimes smaller, sometimes bigger. So the agent is detecting, and then another agent is being informed to do a root cause analysis, looking into the contextualized industrial data graph, and they find out that there is a correlation between the quality index and the material viscosity. So the material viscosity is measured from the plastic granulate, goes into an injection molding machine. So if this is varying, then it has an impact on the quality. So the agent goes further into the industrial knowledge graph and finds out there is a correlation between the viscosity and the age of the plastic granulate. Oh, okay, this is maybe something we can do about it. So the agent comes up with the proposal which says, if you actually introduce a FIFO system for the consumption of the plastic granulate, which ensure that you always use the newest one first, you have the lowest fluctuation in viscosity, and you get your quality index back. So this is what you get out of the context of the industrial data coming from the different systems we mentioned before. Now that recommendation the agent gives back to the operator of the injection molding machine and said, this is something you should actually apply in order to get your quality fluctuation back to a high level again with good quality. So this is a workflow that can be done by a human, can be done in the daily stand-ups, but in the future and today, can be done already by a agentic system in a way that we described before.
No, that was a good example. We talk now a lot about features and the things we need to change, but agentic AI will also bring a lot of culture change and organizational change. So with you, Accenture has a lot of consulting and interactions. What is the transformation challenge and ideas you see, Vlad?
I think the transformation is exceptional because we have a classical three-body problem we're dealing here with, technology, people, and processes behind. The first one, AI is not just a technology because it already today directly impacts the decision-making process and the business core processes of the whole organization.
Yep.
So compared to other technologies, it's not a machine learning topic anymore. It's also not IT topic. It's actually core part of a transformational strategy of each organization. Second, what we see is that you cannot just layer AI on the broken processes and fragmented data. You will still have the same fragmentation just with another tool. And it takes time for organization to adapt and redefine these processes so they are AI ready. And as you just recently mentioned, to make also the data contextualized and ready for AI to consume. And the third component, what we see a lot at the moment, is that AI today which we use is a non-deterministic tool. And it's quite new technology to use in our highly structured industrial processes. So people need time to trust these new solutions, adapt, and find a way how to use it in the right manner. But what we also see a lot at the moment, once they see AI giving value to their daily work, once they see that value created, they actually adopt it, and the organization can move forward together.
Very good. Looking at the time, maybe you have a little bit of an insight about traps and misconceptions down the line. What did you accomplish?
There's actually many misconceptions out there in the market and with customers when it comes to AI and autonomous production. Let me give you three of them. The first one is AI is a magic box. You switch it on and it works. This is certainly not true. We talked about that. You need to have a solid foundation. You have to have a digital transformation program running, and then you put other building blocks and expand those capabilities. It's not a switch on and it works. Second misconception is once you have it, you deployed it, then you can let it run forever. Also not true. AI has different challenges, so you don't need to worry about maybe the last security fix, but an AI model has drift. This is something completely new, which we haven't experienced in the past. This is something that came with AI. So you need to monitor model drift. You need to bring a model back. If you have a model which is self-improving, you need to evaluate and monitor that new model with the new capabilities that you still have the quality and the replies that you expect from that. So there's different things which you need to do once you run a deployed model. And last but not least, the third misconception I want to share with you is just throw more data in AI and it becomes better.
Okay.
It's also not true. It's about the quality of the data, and even more important, as we iterated several times, about the context of the data to give the AI as much structure and guardrails as possible. So it's about having the right expectation, build a solid foundation, and then have a human AI-centric combined approach.
And talking about time, we thank you very much for listening to our conversation here. Let's see what is happening until next year in AI. I mean, looking at the time, and for you, I think the time is to act now to start this journey, because we think it's really when you need a signal, this was it. Just start with AI. Thank you so much.